This is a video overview of the idle screen on an AlphaPix Evolution. This same screen should show similar to a AlphaPix classic controller. The buttons will be slightly different and the screen will have two lines. We're going to go ahead and power up the controller. When the controller first powers up, what we will see is the version of the firmware and the current address. It is now telling us we're entering normal mode. There are two modes: normal, which is where we're receiving data from the network via DMX, and test mode. If we go into test mode, we press and hold the far left M button and we enter test mode. To exit that mode, press and hold the M button again and we enter normal mode. Now, we can use the center button to pause the screen, and that is the S button or select. And we can see here that we press briefly to configure. And so that is, if we wish to configure the controller, we can simply just quickly press this and we'll go into setup mode and see our other videos on how to implement setup mode and all the options you can configure through there. I'm going to go ahead and reboot the controller. Okay, again, we get our firmware version and our current address and the same message we just started with. The next is the Ethernet data input protocol. This controller is designed to receive E131, which is also referred to as SACN and ArtNet. This gives you a quick verification that you are in fact receiving the correct protocol. All right, the next option we have again is the static address, and we will see some other options here. The next is the pixel protocol. This is the protocol being sent out to the controller's pixels that are attached to it, either on long range or on the SPI. Now, this may not be a comprehensive list of all the protocols, as families of protocols often share numbers, such as 2811, 2812, 2813, 2815, and so on. So if you're not sure a particular protocol will work, select a different protocol. There's no harm in doing that. If you purchase HolidayCoro pixels, all HolidayCoro pixels are in the 28 family, and so you can just select 2811. All right, and we're back to, again, static address. We're going to roll back around here. All right, there's our pixel protocol. Now, this is the input voltage. Now, this particular controller has two expansion boards. Expansion board 1 is right here. It's not really easy to see, but there are two ribbon cables connected. This is to port 1 and port 3. The second one in the middle is not. And so what we see is the controller knows that there's a differential expansion board and that it is receiving 12.2 volts and that there is nothing on the second port, and that the third and bottommost port is the SPI board and is receiving 12.4 volts. This is helpful to determine two things. One, that your boards are fully recognized and physically there. If you had a ribbon cable disconnect or other problem, that could be isolated using this function. The second is the voltage. If you're seeing voltages that are not within the range of your power supply, now it is common for the voltage on a power supply to be slightly above the standard voltage. And when we ship our controllers, we do ship them with slightly higher than normal voltages. This, if it were, let's say, 9 volts, indicates that there's some sort of problem. So if you're running your pixels and you do see that the voltage is well below the number that you would expect, like 9 volts for what would be normally 12 volts or 4 volts when you should be expecting 5, take that as a troubleshooting piece to allow you to figure out what may be happening. You may be overdrawing the controller if the voltage is dropped too much. All right, the next option we have here is the temperature. And again, we have all three boards. Each one has a different temperature. Now, the differential board does not report temperature, so that's why it says none. But we can see that the SPI board does. And this is because the long-range board really doesn't generate heat because there's not any real amount of power going through it. But SPI boards absolutely can generate a lot of heat depending upon how they're configured. And in this particular case, we see 69 degrees Fahrenheit, 21 degrees Celsius, and see our other options in the controller that show how your controller can, 1, turn on a fan, or 2, the temperature at which the output stops, which is typically 140 degrees. So if this board were to reach 140 degrees, the controller would stop outputting data to the controller. And that's a safety measure to ensure we don't exceed any particular temperature that could become life safety concerns. Again, that is configurable within the controller's settings. All right, so the next is the SPI fuse state. Now, and this is relevant because this particular board is the board that has a non-LED indicating fuse blown. So on some of the boards that are older, you may have an LED next to each of the 16 fuses that says that the fuse is operational. If it's red, then the light indicates it is okay. If the light is off, it indicates the fuse is blown. Now, on a polyfuse unit, and you can identify a polyfuse unit because they have little yellow squares on the board, those do not blow directly. You do not have to repair them or replace them if they are shorted out. But you want to know if there are any that are shorted out. And through here, you can see that the SPI says all okay. Now, it would be none if your board is an older board and it does not have polyfuses and it has traditional fuses. In that particular case, we use the visual. And the differential and expansion port 2 don't have any fuses. So that's not relevant, and that's why those are blank. All right, so we're going to let it scroll around one more time here. There's our input voltages for each board, temperature, SPI fuse state, and then we're back to the static address. So this is how you can monitor the current state of your controller. And again, see our other videos for actually configuring the controller using the button interface, and also for using the button interface to do test mode within the controller.